first category of connective tissues that we're going to look at is connective tissue proper. Most of the time when I think of connective tissues, I'm thinking of something that is connecting two objects together or binding an organ together, perhaps anchoring something. And this is true of the connective tissue proper. In this group, we have a wide variety that ranges from adipose tissue to tendons. It's kind of weird to think of adipose fat tissue as a connective tissue, but nonetheless it is. It fits all the characteristics. The first tissue we're going to look at here is the areolar tissue. It is located under the skin, so this is one of the tissues that would be binding. It binds the epithelial portions of the skin to the deeper organs. In this tissue we will have a matrix that is gel-like. I always think of this as kind of like a loose jello. It consists of all of the protein fibers. You can see the elastic fibers right here, and then the very thick collagen fibers are located here. I am not seeing reticular fibers, but they are just simply not being depicted and shown here. We do have a variety of cells. We have fibroblasts. Blasts build. Fibroblasts are going to produce the fibers that are in connective tissue. Fibrocytes are the cells that are mature. You will find macrophages. These may be free or they may be fixed. They are going to engulf cellular debris, pathogens, whatever might need cleaning out of the connective tissue. And then we have mast cells here. These cells contain histamine, and upon injury the histamine will be released to induce inflammation. Our second connective tissue proper is adipose tissue. This is a special type of tissue that provides padding and insulation as well as an energy reserve. Notice that there is very little matrix between the cells here. It is populated by cells that are called adipocytes or adipocytes, however you prefer to pronounce it. This is where all the triglycerides, all the fat that your body stores, is located. Reticular tissue provides framework for tissues in the liver and spleen. Again, you have specialized cells. In the liver you would have hepatocytes, for example. They also have fixed macrophages, fibroblasts and fibrocytes, but those are seldom visible because the organ's functional cells are dominating. The reticular fibers create the 3D skeleton for these organs. The next is a dense regular tissue. Dense because the fibers are very tightly packed, regular because they are very close together and they are parallel. This is often only collagen fibers. There are numerous fibroblasts, and there may be some elastic fibers. Dense irregular tissue. This is found in the skin, the periosteum, which surrounds bone, perichondrium, which surrounds cartilage, and the capsules that are surrounding many of the organs. It too is collagenous. The fibers are seemingly randomly arranged. They may have elastic, but some locations are going to have more elastic fibers than others. For example, the aorta and respiratory passages, where not only expansion but recoiling of the tissues is necessary. Elastic tissues. It is very similar to a dense regular tissue, but it has more elastic fibers, and this would be common in the elastic ligaments between the vertebrae.